Alrighty then, good happy Tuesday afternoon to you all. Today we're going to wrap up the AMOC Flips section. The main topics of discussion for today are one, a review of the homework exercise. There might have been a little miscommunication, so we want to clarify all of that problems. And the second topic is basically to talk about, we're going to take a little diversion because we're going to look at a scientific paper that's concerned with defining the exact cause of the 8.2. And I'm doing that as a rationale to give you the opportunity to see that some of these ideas are evolving. We talked about a glacial lake, they're going to modify that. The third thing of new information today is a case study. What happened to a particular civilization in Turkey during the 8.2 year event? Your homework exercise is largely about going and finding another case study, another example of something someplace, somewhere that happened to whatever, your choice, for during the 8.2 event, and then articulating a little bit on that. So that's the continuum here, and we'll shift gears on Thursday to yet another topic, and I think we go into the Younger Dryas on that topic. Before I get started, any questions? Okay, the slides deck that I put up here might not be exactly what you have as a PDF, but for practical purposes it is. The assignment, questions 1 through 3 had a diagram with a map of information and a box. And somehow we miscommunicated what the box was to represent. But basically, the conceptual idea was we had a map with pretty colors up here, and then a box that spanned that, and so that the X distance from the equator to Greenland could be mapped out. And so you were supposed to transfer values on here, and how do you transfer the values on a line from a map? It turns out to be some sort of graph line. And we put numbers on here which didn't necessarily mean anything, they were just reference points. And so the numbers, the way to represent that would be this, or whatever it looks like. That was done for the first two things, and then I see in this section that the questions, that the header of the question and the question it asked weren't exactly the same. But you'd do that for salinity and temperature. One of the challenges in this is that the salinity graph was at a different scale. So you actually had to accordion it out. It covered more area, so you wanted to make it split out. Then you could take those two plots of information and make a third graph of the density. And I didn't ask it explicitly, but I think I made many notes to the fact that, did that density then, was a value for the density? And why were we doing all this? To see when the overturning could happen, or where it might happen. And so from that density, you could figure out, when you plotted, backtracking, a lot of you might have improved this exercise by plotting the values of salinity or temperature or density on this axis. Okay? Then you'd have them. Some people would get a little messed up about that. But with the density, then you could see where the given density was, and I forget what it was, 1.027 or something. And you could actually pinpoint that point where the density came out. Some of you might have interpreted it where the density wouldn't come out, and that's fine, just depends exactly where you took your information from. So that was the intent of that exercise and what we wanted to try to cover. So you were given the X scale, were asked to get out a map for the Y scale value, plot it up, and I said for several of you, and I'll make it a general offer, if you feel confused about it and you're not happy with the score, or you see a better way to do it and you want to redo it, fine, I will reevaluate it, but email it to me directly. Okay? So if there's any confusion about that, any questions beyond that? You have an option for a redo, because I think, well, I'm going to make it an option if you want to. It'll be your motivation to do that. All right, so that's what that was about. This is, why would this be important? Because what are we trying to get out of this is where the overturning could take place, here or there or whatever. because if you change conditions, the overturning will take place someplace else. Questions 3 and 4 were, well, what would happen once if the overturning changed, and it changed as a tipping point? And there's two, the 3 was more about why it might change, and the general answer that could have, at some level, it's just a change in the thermal haline circulation. In other words, it's a change in the conditions here. And you could do that a couple different ways, temperature and salinity. The whole point is the thermal haline here. And I'm trying to be sure that we see that systems can have two things. It's not one nor the other. Most of us were talking about 3 here, temperature change. We also did that with fresh water. But what we didn't do, Megby, as well, is where did the fresh water come from? There were an awful lot of you that said, okay, we're going to have global warming, and the global warming is going to occur, and then all of a sudden, thermal haline circulation flips. We're getting at a point where we shouldn't be making those leaps of faith, basically. We should be talking about all of the steps in between there. That's what we're trying to get across here. So the thermal haline circulation is fine. The source of water might be, or fresh water would be Greenland ice sheet, because you take an ice sheet, you melt it, and there's a lot of green water, and it's right at the right tipping point. Now, a tipping point doesn't necessarily imply, or that mechanism, if you change AMOC, imply a sea level rise. That's typically something that's thrown into the collection terms of the world's going to change, and here's an iteration of words, things that are going to change: the haline circulation, the vegetation, the sea level rise. There's a kind of a list of generic things. The sea level rise will not change because of a circulation pattern change per se. But if it's warm water and you're melting the ice sheet, that mass will actually rise sea level. Now we're going to have a whole unit or whole thing on sea level change, so we'll get into it a little bit deeper. So I wanted to clarify that business. Down the road, the reason we introduce tipping points is because they're not predictable. They're sudden, they're catastrophic. So what if climate change is catastrophic versus the model that you see every day, which is gradual? And I harped on this the first lecture. And so what we're trying to now is present an alternative model for how the future might unfold. Okay, so what's this? This is just a review driven by density. I think you know that, but is there any questions? Or are there any questions in the homework and what we're trying to do and or the general concept? Sir?
So just to clarify, we email you like the, redo the graph?
However you redo the graphs, and I had some creative hand drawings and I had some creative plots on the maps or whatever. However you do them, just send it to me as a graphic.
Okay.
With your name, and I'll change the points on whatever it's called, Canvas, I guess. Okay. Okay? Does that clarify?
Yeah.
Anything else? All right, so there we go. Blah, 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 blah. I don't think we necessarily need to harp on that. What I'd like to remind ourselves, because you'll see this concept coming up, is that the 8.2 is fairly, in the grand scheme of things, compared to some of the things, and this is the one we're going to look at next, may or may not be a big deal. So there's a question. This is an event that definitely happened. We have a pretty good idea of why it happened. It had to do with some sort of tipping point. It, did its thing. The flood, a flood, we'll see an alternative to that, whacked the ocean circulation, but then it recovered itself and got itself going again. All right. Nevertheless, it was because it happened for a couple centuries, it made an impact to some cultures, as we'll see. All right. A theme that I would put about tipping points is I think most of us have the concept of the definitionals on that argument there. The next level of sort of implication is not that a tipping point happens and then the sea level rises or whatever. How do you adjust? If I'm going to tell you that the grades are going to get, the evaluations are going to get progressively harder exercise of the term. That's one thing, right? What if we go along and I grade easy for 2, 3, 4 lectures, and all of a sudden I grade really hard? Which ones are you going to find more satisfying? In other words, if I did a tipping point in my evaluations, you might not be so happy because it would require some adjustment on your facts without necessarily knowing the adjustment was coming. Anticipating that things are going to happen in a certain progression is great. Not knowing that all of a sudden it's going to break and go some other way is less pleasing aesthetically. It's less easy for a lot of the natural systems to adjust. So that's really what I want to get home about the tipping points, is the tipping points imply some sort of behavior of the system that's not particularly identifiable, nor easy to predict. And the theme of a lot of what the events that I'm talking about in the geologic lesson have this underpinning to them, because that's the main point I want to get across in this class. These are not easy to plan for. I'm personally convinced you're going to experience one of them in your lifetime. How do you want to prepare for that? Okay, shifting gears entirely. As I said, scientists are always debating things and we're always having arguments about it. So what's the exact cause of the 8.2 event? Well, at some level, it's the change in the thermal haline circulation. Another thing that I said was, or suggested, was that it had something to do with sudden release of meltwaters from someplace in Canada. This study tried to examine that and test that hypothesis and sort of carry it to the next level of refinement. And so what they did, they're trying to get into causes. We're always interested in trying to get down to the cause. Well, what's the cause? Well, who knows? The popular press is really focusing on melting ice these days. Why? Because the melting ice changes sea level in addition to other things. If the 8.2 event happened because of a catastrophic flood, like we set up here, the chances of it exactly happening again are pretty low, because we needed an ice sheet to have a big lake, and the lake had to drain suddenly, and that's not going to happen again, realistically. If, however, the 8.2 event was more driven by just simple melting of the ice sheet, then the tipping point could happen any time. So there's a subtle difference here. So the press is always trying to get at causes by saying melting ice. And so what's the news feed thing, melting ice likely triggered climate change, the 8.2 event. Okay, that's the message they want you to hear. If we dig into what the investigators actually did, we're going to see a slightly different perspective. And we're going to talk about them. This is the system that they use to get their record. They're going to a place in Scotland by the coast, and they're going to get mud out of that hole, out of the ground with that rig there, and then they're going to talk about what former sea levels did 8,000 years ago. And so just to introduce you to that, here's what the technical paper looks like. The other screenshot was the way you might run across it on a news feed someplace. And so it lists the people, it talks about that. So that's hints about the source of the meltwater. Here's a particular journal. It's not one of the oldies but goodies, but it's a new one. And you could read around this stuff, and they're going to get into some technical details there, and I'm not going to bore you with that details. But they're basically saying, oh, this is a big deal, climate event Holocene, and it's thought to be the ice sheet, the lake draining, blah, blah. But we don't know that, and we're going to try to tweak that. And they tweaked it in Scotland, and they're standing on the salt marsh. And the point of the salt marsh is it's an ecological response to the sea level at the time, and they grow up or they go down. And on photographs, it looks like this. And so if they take that rod and they run it into the ground a bunch of times, they'll get sections of mud at different places. And the bottom of it, the mud will go up in elevation. So they can actually, by taking that out of there, develop what we call cross sections. Here's a core, there's a mud there, mud there, mud there, mud there, mud there, where they drove that thing in the ground. I think that's all. And then you get some sort of information about the subsurface. And one of the information you get is the old sea level at that spot. And we're going to see that that's roughly a few meters below the present day sea level. And that's not news, that's pretty well established. But how they do it is they look for the critters that live in the salt marsh, and they see when they go from saltwater living to freshwater living. And we could go into their discussion, and they've got a lot of Latin names about the ways they do it. But that's the basic principle behind it. From that, they construct a graph of relative sea level. The reason it's relative and not absolute sea level has to do with the fact that the Earth is squishy. We'll talk about this more later. But their graph suggests time, deeper time, younger time. Now it's only 700 years here. And then they say the sea level started sort of deeper than 4 meters, and then it got to about 1.5 meters over that interval. But they are trying to tease themselves and get more detail about this flood. And so they have quite a bit of information, little boxes or age information, and they actually point out that there's kind of not a straight rise here. If we looked at this graph and we extended it a couple thousand years, it kind of looks straight. By zooming in with detail, they say that it's an S-curve. Fine. And then they break it down into different phases. Okay, the details of that, the middle of the two, in the middle, there's 2 slices. There's 2 places here where there's a slight change in that. What they're going to do is they're going to attribute that to the melting in Greenland. And so they're arguing, instead of this model, which is what we presented in class, that there was additional melting coming off Greenland, and that kicked in some water. Now, they're not saying this didn't happen. They're saying maybe it was the combination of both things at the same point. This is the kind of technical argument that we get into all the time to try to understand how the world works better. Does it make a real difference to what we're trying to get across in this topic in this class? Not exactly. But I want you to be sure that you're aware that scientists are making this debate all the time. So if somebody said, well, what caused the 8.2 point event? And so this group says this and this group says that. Doesn't mean the 8.2 event wasn't real. It means that they're arguing about the details. So if we zoom in on their paper and try to reassess what the press said. The press said melting ice. Melting ice. The ice melts because it gets warm. That's a concept we can get across in the public. If you read their tale, our reconstructions, our interpretation, our analysis, and it's only an analysis, it's not necessarily true, suggests that there was more than one meltwater pulse. In other words, there was more than one surge of water. That the ice sheet was melting all the time was one thing. But they said that there was more than one of them leading up to this point. Based on the magnitude of this, we reject the hypothesis that that lake was the major contribution. They're saying, they didn't say it didn't happen, they're saying it's the major player. So they're trying to play up this business here. Instead, it was the collapse of the saddle. What they mean there is, in our model, we had a slightly different diagram of this, where we had ice all the way across here. So that makes a big barrier. They're saying, yeah, okay, that barrier broke, the water went out, fine. The old model was, it was this water. They're saying, oh, but when you broke that ice, you actually shed quite a bit of ice into the oceans, and that, by their analysis, could have been sufficient to do the triggering of the 8.2. Again, it's an example of sort of picking away at little details that produced the major component. So it's the collapse of the Hudson Bay saddle. That's a mechanical collapse. You float the ice up. That has nothing to do with melting ice. So the news feed is a little bit misleading. Everyone you read in the popular press is. So I don't know what. So I wanted to point that out. If you dig into the deeper, they're talking about this, but they think it's broke because it mechanically broke up. Okay? Questions about that whole topic? There was a little sidetrack. that the 8.2 is it's still being investigated. We don't understand everything about it, and that's fine. If there's no, what's the take-home message about the 8.2 so far? Do we, go ahead.
That, well, what I'm taking home is there's a mechanical collapse, and that they're still arguing over it today.
They're arguing, yeah, that's fine. Well, this just came out about a week ago, so the argument's pretty fresh. I mean, that's why I saw it and I said, oh yeah, we're going to talk about this in class.
So there could be multiple factors and not just the fresh water from the lakes.
Do you think multiple factors could be responsible for a lot of the things that we know about global warming? Okay, fair enough. We know they don't talk about tipping points here. Why don't you wonder? Why wouldn't they talk about tipping points? You're saying an event. Well, this jumps. Are reconstructions a cause? So why aren't they making a big deal about tipping points?
I don't know, maybe because they're just talking about like the cause.
Yeah, they're so focused on the cause that the behavior of the overall system, which they're not questioning, isn't the big point. So they've got to spend their time focusing in on the details that they're trying to make a point. They have new information on it. This graph is very detailed. They've done a pretty decent analysis for this thing. There's some subtleties in this, and I could bore you with the details, but that they didn't consider. That's not the real point. They're assuming that everybody knows about tipping points. We're going to figure out why the cause is. Now, so if they're right, and it's this combination of causes for the tipping point, the lady in, if they were right about it, then what does it mean about tipping points? Do they still happen?
Yeah.
They got to still happen, and so but
But there can be several different
they can be different causes. And is the cause as important, perhaps, as the fact that it tipped, or the system tipped? The cause is an intellectual exercise, right? If you were trying to survive during the 8.2 event, would you really care whether it was this block of ice or that block of ice? But it gives us something to do, keeps us off the street, all of that business. All right, anything else on this? I'm going to go to Turkey. I'm going to go to a former village. The village didn't persist through the 8.2 year event. It was a well-developed civilization prior to that, and it went kafuffle at that time. This is not the only example of cultures that gave up the ghost at the 8.2, but it's an example, and it's particularly a good one that's well documented. So it's a former city in Turkey, former. They were very skilled at that time, 8,000 years ago, in agriculture and the domestication of animals. They had a lot of domesticated animals, and they had a fairly complex social structure with a religion. I can't tell you exactly why the archaeologists know that, but it has to do with the fact that when they started uncovering this, and here's some people for scale, this is an archaeology site, they put a roof over it so the rain won't damage it. So this is parts of the old city that existed. And they can tell by the nature and the way that they stored things in various rooms, something about these things. The other thing that they could do, one of the lines of evidence here that they tie it to the 8.2, cultures come and go all the time. How do you know that the 8.2 is the cause for this culture to go belly up? Well, we'll get to that in a minute, but it has back to do with animals. Here's the technical paper. Their evidence for the impact. Evidence for the impact, not that the 8.2 happened or not. They wonder who it impacted, who it affected, how did it affect somebody. And that's what we really care here about. In the Near East, say on early farmers. Okay, so they were farmers, they were in Turkey, reveals animal fats preserved in porosity vessels. So they're going to actually talk about the things that they started cooking their animals with, retain some of the remains of those animals, and they have a chemical compound in them that people are able to analyze. And that's how they're going to tie this to the 8.2. And it's a World Heritage Site because it's a very significant archaeological site. We observed changes in the archaeology, faunal, plants of the site showing that the farming communities had adapted to climate change. Had to adapt. All right, so they changed the planting, the summary, this is the summary. They had to change the plants that they were harvesting because the climate changed. And then they've used a biological or chemical tool to help document that there was a climate change associated with it. So we're going to go to Turkey, a couple slides to zoom us in on where in Turkey we're talking about. We're going to see like the Sahara, this is a fairly arid area, but they were able to, guess what, have a successful agricultural system during the 8.2. Here we are across the Mediterranean. We're going to zoom in just to get some geography, fairly rugged terrain. These are salt lakes, which means that they're basically very evaporative today, and that represents today's climate. We don't see a lot of green in here so far, the way we've scaled in. Here's a couple lakes for scale, there's a dry one. Now we're going to come in and we're going to actually start seeing, oh, there are agricultural lands, but when you look at the agricultural lands, they're little squares, we'll see a little bit, but the notion that they all of a sudden have sharp lines in them sort of implies that they're requiring irrigation. In other words, if this was if all these were naturally growing, some hence, they wouldn't stop here. But we're going to see little plots of land, and here's even more plots of agricultural land, and this is cultural, you know, with different crops and at different times of the year. And in the middle of this is this particular city, or what was the remains of that city. Gentleman with the dark top laptop, yeah. What do you have questions about this as we're going into this about how to pronounce it? I can't pronounce the name of it, but what questions might you have?
Why is that area specifically isolated when all the land around it is blocked out for farming and agriculture?
They've known about this city for quite some time, and so the remains of this city. So they set it aside as a World Heritage Site, so to preserve it for future study and reflection on why is there a city there now, I mean, there's a city here now. That one probably won't get into a World Agricultural Site or Architectural Heritage Site, but yeah. So the former city was here, and they left it largely undisturbed. I mean, that wouldn't be the total extent of the city. That would be where the dwellings were concentrated. And I don't remember if they say how big the population was. I don't remember that. They may. Okay, so what's the evidence of the 8.2 event here? If you want to say that somebody changed and tie it to a cause, there's a temporal relationship. And so you have to have something that talks about the temporal. So it turns out that dating, archaeological dating, with a technique called radiocarbon, is their main tool. And what these little blips do is they show something like the sea level rise. They show different times, and these are different levels within the site. And so they break things into sort of dig packages, and they're all kind of the same. So in that dating, this is going from before the 8,200 year event till after it. 8,200 years is in here someplace, right? They would make an argument that there were certain kinds of plants here. And later, there were different kinds of plants. They would make an argument that, well, this is a ratio, but it changed also. One of the reasons this got tracted is because, like, as I said, they had pottery remains that they used for cooking vessels, and so they still had fats and things in them preserved. And the fats actually contain a compound that reflect the chemistry of the plants, the animals that they were slaughtering. And if you look at that and see that it had a value, and then it changed, and then it changed back, that's the whole 8,200 year event recorded in those plants, or those fats. Not many data points, but it's a fairly good squiggle. Another kind of geologic record that we haven't talked about, but does define the 8,200 year event right here, is from the ice cores. Ice cores are those things up on the tops of ice sheets where they drill a hole down in the ground, like they use something a little more sophisticated than the hand drill that they were there, and they look at the various chemical compounds. And that was how the 8,200 year event was kind of defined, the difference between here and here. And then it goes back to here. So if we flip that, that's the little dip in our big blue graph that we start the exercise with. All right, the lady with the color, what color thingamabob is that? Your drink holder? Yeah. Okay, the lady with the black thingamabobber. What else do we need to know about the 8,200 year event in terms of the evidence, therefore, of it?
I would say how like the chemical makeup of the ice core shows the event that actually happened. Like in what way does it?
How does that work?
Yeah.
Okay, so let's take a dive into that. I don't have any prepared slides for that, so you'll have to just go with the verbal flow. So the point with ice cores is that on the top of the ice sheet it snows all the time. And the snow is precipitation. And precipitation is H2O. It's in the frozen form. And so it turns out that oxygen, part of the H2O, has isotopes. They have the different 8, and oxygen you probably learned in some chemistry class someplace, the isotope 16. One of the forms of oxygen is 18, it's a heavier. Well, because the molecules are slightly different weight, the water molecules, they fractionate or change over time. So if you stand at a spot and you see that change in isotopic value, you're seeing some environmental change. Is that too much, too little? Okay. So that's exactly what this is the isotopic values, and they've got 2 or 3 of them here just to confuse you. But the fact that it switches over and switches back plotted on another map is this dip right here. It's blown up a little bit, it's only one line. But they were just looking at basically that. And if you zoom in on it in detail and you look at those chemical properties, the change in the oxygen 18 basically, it tells you about temperature. Okay? The lady way in the back. What do you need to know beyond what we've already talked about? No questions? Okay. I think this is going to be actually a short lecture day, which I know breaks your hearts, but that's you'll probably figure out a way to get over that. Okay, so this is evidence that it happened. It happened at the right time. It was reflected in chemistry at the site. That's one way they tied it together. And then because they dated it and were able to plot it on this time scale is the other way they tied it together. So it's a pretty good connection. This is, usually you only have one of these, you don't have this second one. But this says, in fact, that the things were subjected to those changes. Okay, now, so what? What actually happened at this site as that happened? And here's sort of a list of things. They basically they had what they call pioneer farming. They had farming mostly with animals that have hooves. Okay? During the 8.2 event, the size of the herd, the cattle particularly, reduced. There seemed to be a lot more broken bones after the point. That's interpreted to be that they were harvesting more cattle because they were hungrier and their crops were failing, so they were breaking the bones. There's also some evidence by the chemistry of the nature of those bones that the cattle were suffering that malnutrition. So those cattle were happy up until the 8.2 event, and then the herd got smaller, in part because they were eating them more, and in part because they had malnutrition. Why? They don't go into it too much, but because the isotopes change, we can talk about the hydrology, and we talked about hydrology changes, we can infer this is a hydrological change here. Other cultural things that happened had to do with the pottery or the architecture, and so they had to change their building style. They went from multiple rooms, as you saw, everybody had their own little space to do this or that or the other thing, to much larger open spaces. Don't ask me why a culture, when it's stressed, would go from small cubby holes for everybody to larger open spaces, but it did. It appears that we went from small, independent, self-sufficient household, replaced the dominant communal structure. Before the event, they were sort of a widespread community that depended on trade, interrelationships with each other, but afterwards, they went to smaller households, living in bigger spaces. So the individuals withdrew back into their family units to survive each other, not the big, happy families. So you could draw an analogy to if something hit Cincinnati, instead of going from something that's sort of cosmopolitan, we might, the size is totally different, but something that gets more, you know, the overhyped thing that you see in the movies of individuals fending for themselves. I'm not saying this happened in a large thing, but it was big enough that they could detect it. Again, I don't remember how big this city is. But even with those measures, the site was not self-sustaining. They couldn't continue their agriculture and their harvesting of the animals, and so they gave up and moved away 200 years later. So that event knocked the city out from being reoccupied. One city, is that a big deal? I don't know. Apparently, for them. And they used some other evidence that I didn't talk too much about to get to those conclusions. All right, so what, gentleman with the green what's a bobble thing? What do you need to know about, sort of, this is just a list of what happened. What's not clear about what might have happened to those folks?
I'm kind of just impressed that they were able to survive that long and adapt to some situation that quickly.
I think from my understanding of a lot of archaeological sites, there was always a debate why a city was abandoned. And the debate has to do with, well, there was a war and something happened, or there's also an argument that the environment changed so they couldn't hang on. But most of those sites where they know something about them, it does take them decades to give up on it. It doesn't mean they all walked away the same day. The population just got less and less, and then finally somebody said, well, I'm a nomad, I can go someplace else anyway. I don't have to stay here. So the fact that they did it sort of in 2 centuries is, that's short. That's real short in geologic time, but that's long in cultural time, right? Does that make sense? Yes, sir.
So where do they migrate to? Do we know?
No.
Like the city above?
I don't know. No, the city above I don't think is that old.
Oh.
So I don't know, if we go back to this graph, I don't remember reading where they said, because I don't think they would have any evidence. But, you know, did they just go, well, this is longer than a day's walk, that's for sure. I don't have a scale in that, do I? I mean, they could say, okay, well, we're going to migrate to the coast, or we could migrate over to this lake. I mean, they wouldn't migrate from here to here, probably. They would seek out fairer areas. I mean, again, but these lakes and stuff suggest an area that's hydrologically sort of on the edge today, even. And that's part of the reason that I talked about a lot of vegetation, no vegetation. You've seen that before. Transition. So if you lose a little vegetation here, so what? Well, we also know that 8,000 years ago, roughly, this was when all the lakes were down here, right? So this was lush living at some point. Well, sometime at the 8,200-year event, and they may or may not overlap, this was painted as being more lush and then wasn't. So where would they have gone? I don't know. The zoomed in average covers about this much, or sort of half the length of Israel. So it's wouldn't be an insurmountable journey to go depending on how they were getting there. But I mean, they weren't driving down the interstate. But. Other questions we need to know? What happened to them? Okay, so we're going to get the homework shortly, but what one of your charges to do is document that there was an 8,200-year event happened to someplace else. It doesn't have to be a culture or a city. It could be a population of something or something else. And then a list of what actually happened. Did you have a question? I thought you raised your hand, sorry. So find the equivalent of this kind of information to report on for the assignment here today. Okay, so here it is. Case study 2. It's going to be a whole range of things. Some of you, there'll be some that quite a few of you get the same one, and that's fine. Search for a study, and here's a resource where you have to go out thrashing around with the 8,200-year event and something that made some impacts, however you want to do your searches. One question is, what kinds of evidence are there that the area experienced some climate change? And in this particular one, the evidence that there was some climate change wasn't the ice core, because the ice core is over in Greenland. It was the change in the chemistry of the fats, and it was the change in the plants that were living there. That's what happened locally. So what is that study area experienced some climate change? If you can quantify the amount of it, that might be hard. Was it a degree temperature change, half a degree, 5 degrees? If you find something about temperature degrees, it's going to be something on the half to a degree change. It's not going to be 5 or 10 degrees. If you're thinking about that much, there's some confusion about what you're having there. And there's some of the places will have hydrological events and some of them won't have associated hydrological events. And then particularly, what kind of human changes? In the case we just talked about, is they gave it up and went someplace else after their population decreased. So the impacts in our case study 1 is that the population changed its style of living, dwindled, and then moved on. In 100 years, or I don't know, 5 generations or whatever it is. Okay? So you see what we're asking for, makes sense what we're asking for now. Okay? Do you? Do you have a question on it? No? All right. Okay. To tidy up the AMOC thing, anybody seen this particular movie before or heard of it? No. This used to be like years ago. This was the movie, and we could tie it. I could tie it in class. So this is a futuristic. The world changes, and we've got a hero that saves the day. And so basically, what they argued is that some ice shelf collapsed, and this is the storyline. And this is some things that actually happened. And this is the storyline according to the set up the movie. And the movie basically has New York City getting a superstorm that freezes it up overnight. All right, and it's going to be, the underlying cause, this is modeled after AMOC, or AMOC changes. The ice shelf did collapse. It isn't going to do, that ice shelf in Antarctica is not going to do anything in the northern hemisphere, but it did collapse. The ocean cooled. You can see why they would say that this collapsing would cool the ocean. And then you say, well, yeah, that's in the southern hemisphere, so it transmits to the northern hemisphere. So technically I'm picking this apart. That forms supercell, 3 superstorms at high latitudes. And it pulls the cold air from the troposphere way up in the atmosphere, down, and flash freezes the place, you know. And so you have your heroes trudging through a snowfield or snowstorm or something, and bitter cold. And the troposphere mixing is actually a real thing. We don't see it much on a day-to-day. And then so of course people headed south, and our hero went to save his spouse or whoever. It was a scientist, of course. It was a hero, you know. It had to be a scientist, but climate scientist. Anyway, this is a movie modeled after AMOC. And you've never seen it. Next, I'm going to talk about ecological, and those are mostly large mammal reorganizations during something called the Younger Dryas, which is not the 8.2, not what we're doing here, but a big drop, sort of 12 to 10,000 or 11,000 years ago. So we're going to go longer time scales. We're going to go a much larger magnitude event, and we're going to see much larger impacts. Okay? Now, 50 pointers. Question 1, the evidence. Give me a link so I can double check what you did there. What are the cultural changes? What happened to the folks? If it's a cultural, or it might be human and cultural, or it might be a vegetation thing. Most of them are going to be human culturally fine. You're going to see a form of this sentence every week, so get used to it. And then, is that a big deal or not? It's a subjective argument. Now, do I have any questions? All right, it's fairly early, but I will make a deal. Anybody that wants to start looking up for their site now and showing it and double checking it with me, I'll say, yeah, that's a good one, or maybe try again. So, or you're free to go, of course. And I know I'll be sitting here until my next class, but that's okay. If you want to start just to see if that's a good site or not, or have any other questions, then that's fine by me. Otherwise, I'll see everybody on Thursday, and we'll start with the Younger Dryas. Sir?
Do we have to find like a new website?
Yeah, you can't use that same one.
Okay.
Anything else besides that one.
Okay.
There are several, but there will be sort of, probably totally in the class will be like a half a dozen. So a lot of people have the same one, which is fine. I'm trying to drive, what am I trying to do? I'm trying to drive into you that these climate events actually matter. Okay? And did this one, which is a itty bitty blip on this thing, did knock off or change the, it didn't kill every, it wasn't the instant cold that froze them out one day after tomorrow. It took several decades for them to say, it ain't worth it here. Okay. I'm available to give you a hand if you want, or you're welcome to go enjoy the scenery if you want. Sir, why didn't you ask questions when
It's more personal.
Oh, okay, fine. All right.